Hello, my name is Daniel. In this lesson, we're going to be talking about how the Pythagorean theorem and this idea that we've been introduced to in trigonometry, that the sine of any angle theta squared plus the cosine of that angle theta squared has to be 1, how those are related. So we've heard of SOHCAHTOA. What does that mean? That means the sine of an angle theta is the opposite over the hypotenuse. Opposite over hypotenuse. And this is when we have an angle theta right here. Can you see that? We can see that. That's the opposite, that's the hypotenuse, and that's the adjacent. So, and the cosine of theta is the adjacent over the hypotenuse. SOHCAHTOA. The TOA is not super important right now, but we can write it just for the sake of completeness. That is O over A. Opposite over adjacent. Now, what is this sine theta that we're squaring? Sine theta is opposite over hypotenuse, so squared. Opposite over hypotenuse squared plus adjacent over hypotenuse squared. And the question is, does that equal 1? If so, why? Let's review the Pythagorean theorem, where, again, we have a right triangle, just like this one was a right triangle. Oops. AB, and the hypotenuse is C, right? A squared plus B squared equals C squared. Okay. Now what we notice, we're going to connect this to this formula, and we're going to see if indeed this is supposed to equal 1. What we notice here is we should have h squared on the bottom. O squared over h squared plus a squared over h squared. Does that equal 1? I don't know. All right. On the next line, we're going to combine them. We have h squared on the bottom, and we have o squared plus a squared on the top. Now, if we just rename these a, b, and c to o, a, and h, so o, a, and h, right? O squared plus a squared should be h squared because h is the hypotenuse. The sum of the squares of those two legs equals the square of the hypotenuse. So this here, o squared plus h squared, should be h squared. That would be h squared over h squared, and that would be 1. Thank you for listening.